In this video, we are going to talk about graphing rational functions with slant asymptotes. A graph with a slant asymptote is going to have the degree of the numerator that is one more than the degree of the denominator. And you can find that slant asymptote by division, and you can do long division or synthetic division. So I'm going to skip example 1 and 2, leave that for you guys. I'm going to do example 3. So in this one, we have 2x cubed plus 2x over x squared minus 1. First thing you want to do is get the y-intercept, because you can find that in unfactored form, and that y-intercept is 0, 0. Then we'll factor it. Now I can get the x-intercept. Remember, you get that by setting the numerator equal to 0, because that denominator multiplies over to the 0 anyways. So I get 0 equals 2x, 0 equals x squared plus 1. So I just get 0, 0. That 0 equals x squared plus 1 is going to result in an imaginary, and we're not going to use that because we're using a real number plane. Our vertical asymptotes are x equals 1, x equals negative 1. And to get our slant asymptote, we will do division. So x squared goes into 2x cubed 2x times. Remember, we don't need the remainder. So y equals 2x is our slant asymptote. That is y-intercept form, or sorry, slope-intercept form. And my intercept is 0, 0. And my slope is 2. So I can go up 2 over 1. And then that is my slant asymptote. Make sure you label, of course. Now I have my vertical asymptotes at x equals 1 and x equals negative 1. So now I have to figure out where to graph this. Well, I know I have graphs in these sections up here in this upper and lower section because we don't have any intercepts up here or over here. So there's no way the graph is in that section. So they must be in this lower region here and this upper region here. Now we need to figure out, what does that middle section look like? So that middle section we can figure out by looking at the multiplicity of the denominator, remember. So the multiplicity of our denominator is odd for both of those vertical asymptotes. And so I know that on either side I must be traveling in the opposite direction as what's on the other side of my asymptote. So there we go. And then my domain is going to be everything except my asymptotes. There we go. All right, example 4 is x cubed plus x squared over x squared minus 3x minus 4. So again, y-intercept, it's going to be 0, 0 because x is 0. And then I can factor that to x squared times x plus 1 over x minus 4 times x plus 1. Notice that x plus 1 is in the numerator and the denominator, so they're going to divide out to give you a whole at x equals negative 1. To get the y value of that, remember, we're going to plug that negative 1 back in, which means our whole is at negative 1, negative 1/5. To get your x-intercept, you set the numerator equal to 0. So 0 equals x squared. So again, 0, 0. I don't use that x plus 1 because that divided out to be a whole. So all I'm looking at to get the rest of my characteristics is this x squared over x minus 4. My vertical asymptote is x equals 4. And then to get my slant asymptote, I'm going to divide. So I get a slant asymptote of y equals x plus 4. So that means I have a y-intercept up at 4 here for this line and a slope of 1. Got my vertical asymptote at x equals 4. My x-intercept at 0, 0, and then that hole at -1, -1/5. Alright, and then I can draw my graph. It's going to look something like this. The reason I know that it touches right here at 0, 0, and then goes back down is because if it kept going through 0, 0, say like this red line, it would have to come back down and pass through the x-axis again, but I don't have another x-intercept. So I know it just touches at that 0, 0 and then goes back down. Last, I need my domain. Remember, we have a hole here. So my domain is -infinity to -1, -1 to 4, and 4 to infinity. I leave the rest of the problems to you, and there is an example 5, so don't forget about that.